Okay, so this is the the most dreaded type of problem. We're going to solve the orbital condition for the radius in something where we have the period, right? This is the worst case scenario, right? So again, we say centripetal force, satellite mass, times 4 pi squared r over t squared. And I chose this version of centripetal acceleration. This is just our centripetal acceleration, right? I chose that because we're given the period. Now I could actually figure out, not good, no other way to do it, so there's no way around that. Okay, so I've got to choose that one, and then I'm going to go that equals g mass of the central body, which in this case is the sun, times the mass of the satellite over r squared. Okay. So now we're set. We're going to solve that for r. At least that's what we are going to do. Okay, so 4 pi squared r times r squared is r to the third equals gmc t squared, right? And now we're solving it for this guy here. So let's divide by 4 pi squared. Ta-da. And then r ultimately equals the cube root of gmc t squared over 4 pi squared. And again, you either have to use the thing in your calculator that makes it look like this. So go second math 4 and pop up that cube root, right? And then use the fraction, go with, I don't know, alpha or something like that, f1. Make that little fraction thing. Or you got to put this denominator in parentheses. Okay? So I'm going to go cube root of, now unfortunately my calculator doesn't do that, so I'm going to have to go cube root of 6.67 e minus 11 times the sun, which is 1.99, e30 times the period squared, so 3.16 e7 seconds, right? And then I'm going to square that guy. And then I have to go divided by left parenthesis, so continue here, right? 4 times squared. I know you don't need the times there, I just do it because it's always bad to assume you know what it's going to do. Okay. Yes, that'll work. Okay. So cube root, let me see if I can find the cube root on this. Is there a cube root? I can't even find math. I've got a TI-86 here. So it's, oh, there it is. Okay. Oh, no, I don't know. Okay, good enough. I'm gonna do what I'm gonna do is I'm gonna do a cube root. So let's pretend I do a cube root, and then I'm gonna go 6.67 e to the minus 11th times 1.99 e to the 30th times 3.16. If you didn't know any better, this is the 3.16 is what I'm doing here, right? That's the same number there. 3.16 e7. But I gotta square that guy, right? Divided by parenthesis 4 times pi squared, right? End parentheses, so I'm ending the denominator, ending that thing, and then because I couldn't find the cube root, what I'm doing is I'm just tacking on a raised to the 1/3 power, right? So you can do that, or you can go raised to the 1/3. And because I don't know where it is on my calculator, that's what I'm doing. I had to think a long time about that. And then it gives me this very unhelpful number. It's like 1, 4, 9, 7, 3, 7, 6, 8, 4, 4, 6, 8. Sweet mother, look at that thing. That's so unhelpful. And there's no simple way to turn it into scientific notation. I can't just go E equals and do it. I wish I could. So I got to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1.5 50 times 10 to the 11th meters. And of course, this whole thing's been cooked up. 3.16 times 10 to the 7th seconds is a year, right? Because that would be 365.224, something like that, right? Times 24 times 3600. Try that, right? Times 24 hours a day times 3600 seconds is, yeah, 3.16 times 10 to the 7th seconds. So I just concocted this thing with the period of the Earth, and of course we got the distance that the Earth is. This is 1 AU, which is how far we are from the sun. You could have stopped listening about a minute ago, and you'd be like really happy. Okay, so these two atoms are walking down the street, and one says to the other atom, he says, I think I've lost one of my electrons. And the other one says, are you sure? And the first one goes, yeah, I'm positive. You think I'm going to stop now, don't you? I'm just going to keep talking. Okay, guy walks into a bar with his pet giraffe, right? And he gets to talk, and the giraffe lies down on the floor and falls asleep, right? After a while, the bartender looks over and says, hey, what's that lion over there? The guy says, it's not a lion, it's a giraffe. Okay, you know, when you see the geese flying, like in the springtime, right? You know how they make a V, but it's always like shh, the V is always like this. It's always longer on one side. You know why that is? It's because there's more geese on that side. So like this side might have just like 1, 2, 3 geese. This one might have 1, 2, 3, 4, 5. This one I might have 6 geese. That's twice as many geese, so it's going to be longer. All right. Okay, this guy's driving down the road, right? And this guy comes over the top of the hill, and some guy yells out the window, coming the other way, yells out the window, goes, pig! And the guy goes, well, you're not so good looking yourself. And he drives over the top of the hill, and he hits a pig. It's like right in the middle of the road. All right, I better stop this.